Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about Panspermia. So let's dive right into it. Well, first, what we are talking about? We are talking about a hypothesis, not a theory. It's not proven yet, so it's not a theory, it's a hypothesis. And the whole idea of this hypothesis is that life did not start here. It evolved here, but did not start here. The starting point is somewhere else. And basically, life was seeded here by some other mean, be it galactic dust or be it some comet or meteorite or something like that. Now, if this turns out to be true, that means we are of alien origin. Basically, we did evolve here, but we are not from here. So our basically technically we ourselves will become alien if that turns out to be true. Now, versus evolution. Now, this would be the first question many people will have. Does that make evolution not true? Short answer, no. Simple reason is evolution is already proven. It's not proven by one data point. We have hundreds of data points, and all the research that are being done at the point of evolution at this point in time is for refining it. It's no longer like, oh, it's true or not. It's like how precise we can get our studies down at this point in time. So it's proven. Now, all it will do is affect the origin aspect of it, not the growth aspect. Evolution is like, you have a bird, how can you have one bird species and get 10,000 bird species out of it? How you can have a very basic mammal and then make a super advanced human out of it? That's the whole point of it. So evolution is proven, tested, and it's not gonna change. It's just gonna change the abiogenesis state, which evolution does not have an answer for. That's not its department. Abiogenesis is the biggest hurdle at this point in time. Where could we take organic chemistry and make it into a functional life? That jump from chemical to life is the biggest thing. And for the many reason why people think that it did not happen on Earth is simply because the earliest life form that we have found, it was way too early. Like planets started to cool down and bang, life. So either A, life is very, very, very common, or B, life already had a head start somewhere else in the galaxy and then it got seeded here. So basically it was like a safe function. It's like life evolved, became a proper stable thing, and then dumped, save file was dumped on Earth, and then from Earth it took the next path. So it just moves the starting point. It will not change anything about evolution. So be very mindful about that. Now let's understand the evidence aspect of it. Now there is no direct evidence, however there are things that are pointing towards this. That would be the correct way of saying it. It's like many rocks do what we call interplanetary journey. It's a common thing. Like we have found rocks that naturally come to from Earth to Mars to Earth, like this back and forth. It's a common thing. Once we started to understand how these are happening, it's like, oh, we are finding it every place. From Moon also that's happening. So it's a common thing on a basically inside a solar system. That's a rather common thing to happen. Then whenever you are talking about long journeys, like a very, very long journey, like hundreds and thousands of years of journey, you need a lot of energy to do that. How can you dump that kind of energy on a rock? Basically big impact event. So whenever you're talking about very big impact event, let's say a planetoid level collision with something, a fully fledged planet, or something as powerful as what wiped out the dinosaur, that will dump enough energy on enough material that those material will not only go to orbit, they will escape Earth's gravity. So fundamentally that means there is enough energy dumped out of enough mass that it could basically break free the gravity well, so it can escape from gravity system. Now will it escape the solar system? That depends. Some scenarios it should happen, in some scenarios it would not happen. Depends like how other things are, or heck, it could get ejected slowly also. So it's like, it got another gravitational assist or things of that nature, because this journey is very long, and it's not like, okay, it happened and hundreds of rocks are going in one direction. It's like, random chaos at this point in time. And we have the fact, like we already have this point, and Oumuamua changed everything. It's simply because it became the first known interstellar object. Now be very mindful, when we are talking first known, it does not mean this is the only rock there is. It's just the first one that we have spotted. There could be hundreds at this very moment in time that is going through the solar system. We just do not have the technology to monitor them, all of them, and have not spotted them. So that could be very common, very normal scenario. But this opened our eyes. So we went from looking at our solar system as a static body. It's like, planets are planets, they do not interact with each other, to like, no, they do interact with each other. And to even realize that we could have interaction from extra solar system things. Exoplanets could also interact with us indirectly, of course, but it could happen. So it's we are starting to see our space as a dynamic system. It has like things going from point A to point B. So there are some hints of evidence. Now again, rocks is one thing, life form is a different thing. Now be very mindful, when we are talking about life form, we are not talking about little green man. We are talking about something more equivalent to endolithic life forms, simply because these are life forms that live inside a rock. Like that's how shielded they are. Like they are living inside a rock. This is normal thing that this exists on Earth. So what does this mean? This simply means on a collision event, they will be shielded from almost everything. They will only have to be robust enough to survive G-shock. If they can survive the G-shock, they do not have to worry about it, because even if they are going through ejection and the outer layer is melting, let's say there is a big boulder, the outer layer will melt and will quote unquote protect the inner layer, so they are safe. Once they are going through the void itself, as in like the space, the radiation will not penetrate deep enough, so again they are safe there. And many microorganisms can direct survive vacuum, direct survive being dehydrated, so that is not gonna face too much of an issue. And if the rock is still big enough, it could easily land onto another planet without being destroyed. So there is like enough data points that are saying that it is not super easy. It's not something like, oh, I'm gonna send 1 million life samples, all of them gonna make it. It's like, but if you send 1 trillion, few of them will make it. So there is hope in that department, and many microbes can survive for short periods of time in space directly, like from tardigrade to other life forms that we did not even think about it. It's like, whoa, they are just lolling it. It's like, nope, I don't care. Like we could literally contaminate other things on other solar systems just by have microorganisms that are surrounding the outside of our spacecraft. Apparently we are finding microbes on the outside of ISS, and they're not coming from the inside, they're coming directly from the outside. So things of this nature could happen. So we have rocks that are the transport vehicle, we have organisms that are the passenger. So we have these two elements that are helping us, and the fact that evolution started way too early, that is also pointing like there is some missing element of this story. Now, one thing you have to thoroughly understand it. This is one of those theory, hypothesis, whatever you want to call it, that is unknowable. We can never know it, simply because this question has way too many variables. It's like asking whether there are aliens or not. Well, no, we will never know that unless we have like basically galactic level study of every single galaxy. Until then we do not know. We simply cannot know because we do not have enough variables. The only way we could have a proof, quote unquote, if we look out, we could have proof, is that quote unquote almost DNA based, like basically same quote unquote architecture of life is found everywhere else in solar system. Basically from let's say Europa, we find, hey, something else is there. Now we know for a fact that it's much more likely that something coming from outside will dump first in Europa, then dump on Earth, then rather than like Earth to Europa. So we will know like the fact that life can jump from one celestial body to another, that would be proven. So that's why I'm saying, like, if we find life somewhere else where humans have not brought it there, we know for a fact that life can jump from one celestial body to another. So that will prove Panspermia to a point where it's like, no, this happens. Is just like how much, what extent, those will be the another questions after that. And even if we do not find something like that, let's say we became like Expanse in the TV show, and we are studying the whole of solar system, we could still be in a point where they are, hey, I don't think we have any evidence for life hopping. Does not mean that it never happened. It simply means it did not happen here. So that's a very critical aspect. That's why I'm very clear about this. This is unknowable. No matter what you do, you will never find out unless that condition happens, like we find equivalent life form somewhere else. And then if you want to understand it in deeper context or simpler context, you can think of it as just like aliens. It's like there could be alien in Andromeda galaxy at this very moment. We'll never know. Even if they are sending a radio signal at our direction, we will never know. We just have to wait the light lag, which could be in millions of years. So you get the point. Like fundamentally, this is an unknowable task. However, then you might be like, okay, then if it's unknowable by mathematical design, why the heck people are spending their time and money into this? Well, it's a very good question for biological research. Think of this way. Evolution was like, for many people, it's like, what's the point of knowing that? But it helped our medical science a lot, like fundamentally a lot. So whenever you are talking about something like this, it's not what we can learn today. It's like what our future can, like we are building tools that our future generation will use. It's something like that. So figuring this part out, maybe our future generation finally figures out, like our ancestor figured these things out, and now we have the technology or means to figure out this missing block, and then we'll have abiogenesis. So fundamentally, that's a very, very important research for biological life form. Like we did not even thought about like, hey, what will happen to a microorganism life, outside of vacuum? Like now we know. So that's the whole thing. It is unknowable, but it's a really useful tool from biological data point. For other people, I will say just, it's not that useful for most of us. But for biological scientists, that's awesome. And for most of other people, just watch Expanse because it has something similar. Proto-molecule. So this was my presentation on Panspermia. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.